This is a fish. And so is this. And so is this. And so is this? Hang on. What the fuck is a fish? Let's go back to our carp. This is what most people think when they say fish. It lives in the water, it has scales, it has fins, it breathes through gills. It's a fish. Easy. But here's the thing. The moment you try to write the scientific definition of what a fish actually is, things get uncomfortable very quickly. Because depending on how you define it, either almost nothing is a fish, or you are a fish. And that contradiction sits right at the heart of one of biology's oldest tensions, taxonomy versus phylogeny. Before we get into fish, we need to understand what these two words actually mean, because they sound like they're doing the same job, but they're not. Think about your family for a second. You and your sibling share two parents. Your cousin shares only his grandparents with you. So you and your siblings are more closely related to each other and to your parents than your cousin. But all of you and your sibling, and your cousin are equally descendant from those same grandparents. The grandparents don't belong more to one of you than the other. That's the core intuition behind two different ways of drawing the family tree. Taxonomy is the older system. It's the science of naming and grouping living things, putting organisms into categories based on shared traits. Fins, scales, gills, four legs, warm blood. Taxonomy asks, what does this thing look like? And what does it do? Phylogeny is about ancestry. It's the science of evolutionary relationships. Who is more closely related to whom? Tracing lineages back through time. It doesn't care what something looks like. It asks, who is this thing's family? For most of history, these two systems agreed with each other. But when we start mapping the actual tree of life, some strange things fall out. Back to our carp, let's try to write the definition. First attempt is a fish is any vertebrate, any animal with a backbone, that has gills. Simple enough. The carp has gills, the carp has a backbone, the carp is a fish. But wait, human embryos have gill slits. So do the embryos of dogs, lizards, and birds. At a certain age of fetal development, almost every vertebrate on Earth has gill structures. So under this definition, you were technically a fish, briefly, in the womb. Okay, let's tighten it up. A fish is any vertebrate whose gills are functional, not just fetal structures, but primary means of breathing throughout life. Better, now we've excluded land vertebrates. The carp still qualifies. Most things we'd call fish still qualify. But now we've let something else in. The hagfish. The hagfish is a slippery, jawless, slime-producing creature that lives on the ocean floor and breathes through functional gills its entire life. By our definition, it's a fish. And here is where phylogeny starts causing problems for taxonomy. Because if the hagfish is a fish, then look at where it sits on the tree of life. The hagfish sits way out here. It branched off from the vertebrate lineage before jaws even evolved. It is, in evolutionary terms, extremely distant from the carp. Now look at where we sit. Humans, mammals, we're over here, much, much closer to the carp than the hagfish is. The carp and a human share a more recent common ancestor than the carp and the hagfish do. So if the hagfish is a fish, and the carp is a fish, and humans are more closely related to the carp than the hagfish is, then by the logic of phylogeny, humans are fish too. So are frogs, lizards, and every other tetrapod. Every land vertebrate that has ever lived. This isn't a joke, this is the actual conclusion that falls out of the math. This is the collision between taxonomy and phylogeny. Taxonomy, in its traditional form, grouped animals by observable traits. Fish have gills and live in water. Mammals have fur and nurse their young. These are clean, intuitive categories, and for thousands of years they worked well enough. But phylogeny doesn't care about traits. It only cares about ancestry. And ancestry tells us that fish, as a category, is not a real evolutionary group. It's what biologists call paraphyletic. Paraphyletic groups are groups that include some descendants of a common ancestor, but not all of them. You can't draw a single clean branch on the tree of life and label it fish without either leaving out the hagfish or pulling in every land vertebrate. Compare that to a group like mammals. It's a clean branch. Every mammal descended from the same ancestor, and that ancestor's descendants are all mammals. Biologists call that a monophyletic group, or a clade. Clades are the gold standard in phylogenetics. Fish is not a clade. It never was. So, where do we draw the line? The honest answer is it depends on what you're trying to do. If you're a fisheries biologist, or an ecologist, or just a person standing in front of an aquarium, fish is a perfectly useful word. Taxonomy gives us a practical vocabulary for talking about the world. But if you're trying to understand the actual history of life on Earth, or the ancestry of the animal in front of you, the real branching structure of evolution, then fish falls apart. Phylogeny forces you to either accept that tetrapods are fish, or accept that the hagfish is something else entirely. This isn't biology being pedantic, it's biology being honest. The tree of life doesn't give a fuck about our categories. It just branches. Now, everything we've talked about so far has been a biological problem, but if you paid attention in the beginning of the video, I showed you an invertebrate, a bumblebee, and said that this also classifies as a fish. Because, despite the fact that they're not vertebrates, taxonomy doesn't just live in science. It lives in law, too. And when legal definitions collide with biological reality, things get really absurd. In 2022, California Appeals Court ruled that bumblebees are fish. Not metaphorically, not as a technicality. The court looked at the evidence, considered the arguments, and said, yes, under California law, a bumblebee qualifies as a fish. Here's how that happened. California has an Endangered Species Act, the CISA, which allows native species to be listed as endangered or threatened, giving them legal protection. Conservation groups wanted to list 4 species of bumblebee under this act, because bumblebee populations in California have been collapsing. The problem? The CISA only explicitly covers birds, mammals, fish, amphibians, reptiles, and plants. Insects are not on that list. So the question became, can a bee be protected under the act? And the answer the court landed on was, well, look at how California law defines the word fish. The California Fish and Game Code defines a fish as a wild fish, mollusk, crustacean, invertebrate, amphibian, or part spawn or ovum of any of those animals. An invertebrate. A bee is an invertebrate. Therefore, under California law, a bee is a fish that bumblebees were eligible for protection. Case closed. The word fish in this legal context had quietly expanded over the decades to cover the entire ocean floor. Mollusks, crustaceans, all manner of spineless sea life such as calamari or an octopus, because all of it fell under the jurisdiction of the Department of Fish and Game. Nobody updated the definition. Nobody thought it would ever matter. And then one day it mattered very much, and a judge read the statute, shrugged, and protected a bumblebee as a fish. This is taxonomy doing what taxonomy does. It draws a boundary, slaps a label on it, and then watches as that label slowly drifts away from anything resembling the original intention. The biologist looks at a bee and sees an insect, a hexapod, an arthropod, something that last shared a common ancestor with a fish roughly 500 million years ago, closer to the beginning of all complex life than it is to the split between the hagfish and the current fish. neither of them is wrong. They're just playing different games with the same word. And that's the thing about categories. Whether you're a scientist or a judge or just someone trying to figure out what the fuck is in their aquarium, the category is never the thing itself. It's a tool, a handle, a useful fiction we agree to uphold until it stops being useful. The bee doesn't know it's a fish. The hackfish doesn't know it's causing me a lot of existential problems. And the carp just keeps being a disgusting, invasive carp. Now, let's talk about the hagfish, because we've only used it as a plot device so far. A philosophical wrench thrown into the gears of taxonomy. But the hagfish deserves more than that, because the hagfish, as disturbing as it is genuinely one of the strangest animals on the planet. And the deeper you look at it, the worse the already terrible classification problem gets. First, let's look at the animal itself. The hagfish looks like someone tried to make an eel out of a catfish. It's a long, soft, pinkish tube of a creature with no jaw, no paired fins, no scales, and eyes so degenerate they've been almost entirely swallowed by skin. And that's just by looking at the top part. Looking at the bottom part, it's even more horrific. They live in cold, deep ocean water, mostly on the sea floor, and they eat by doing something that is genuinely upsetting to people that first hear it. And it's about to upset you too. When a large animal dies, it sinks to the bottom of the ocean floor. The hagfish finds it, and it buries itself directly into the carcass, and eats it from the inside. It rasps away at the flesh with a specialized tongue-like structure lined with teeth. This ugly thing. It absorbs nutrients directly through the skin while it works. It has been found completely inside the body cavities of dead whales. When threatened, it releases slime. Not a little slime, an almost incomprehensible amount of slime. A single hagfish in under a second can fill a bucket with a thick, fibrous, clogging gel that suffocates the gills of any predator stupid enough to try to eat it. The slime threads are, by weight, one of the strongest biological fibers ever measured. It can also tie itself into a knot. Literally, a hagfish will loop its own body into a knot and slide the knot forward along its length to generate leverage, or to wipe slime off of itself. Now, everyone likes to list off the fun fact that octopi have 3 hearts. But the hagfish has a one-up, as it has 4 hearts. It is, by any reasonable measure, a deeply alien thing, and here it is, on our planet, in our oceans, largely unchanged for over 300 million years. Hagfish fossils from the Carboniferous period look essentially identical to the ones alive today. Now, for context, the Carboniferous period was when insects were ruling land, which is well before the therapsids, well before the synapsids, well before the age of reptiles, which is the Mesozoic, which is when dinosaurs lived, and well before us. While the rest of vertebrate life was busy evolving jaws, limbs, feathers, and abstract thought, the hagfish looked at the ocean floor and decided, this is good enough. Now, here's where it gets complicated, if it wasn't complicated already. We said earlier that the hagfish has functional gills, lives its entire life in water, and therefore qualifies as a fish under a revised definition because it's a vertebrate. But here is the second problem with the hagfish that we haven't addressed yet. Hagfish weren't considered vertebrates at all. Think about that word for a moment, vertebrate. It means an animal with a vertebral column, a spine made of vertebrae. The hagfish has a skull, a partial one made of cartilage, just like the shark bones, which is why it belongs to a group called Craniata, meaning skull havers. But it has no vertebrae. Its body is supported along its length by a simple rod of cartilaginous tissue called a notochord, the same structure that appears in embryos of all vertebrates before the actual spine develops. In hagfish, it never develops further. The notochord is all they get. So, does a hagfish have a vertebral column? No. Is it a vertebrate? That depends entirely on who you ask and which definition you're using. For most of the 20th century, biologists placed hagfish outside the vertebrates as kind of an evolutionary cousin. Close enough to be related, not close enough to be included. The family tree had hagfish on one branch and all other true vertebrates, lamprey, sharks, bony fish, tetrapods, on another branch. But then molecular phylogenetics arrived. Instead of comparing anatomy, scientists started comparing DNA directly, and the genetic data told a different story. It grouped hagfish and lampreys together as cyclostomes, a clade, and placed that clade inside the vertebrates. Which means hagfish might be vertebrates after all. Vertebrates that lost their vertebrae at some point or never fully developed them, depending on how you read the evolutionary history. The anatomy says one thing, the genes say another. The definition of vertebrate is now genuinely contested because of this one animal. So let's take stock on where we are. We wanted to define what a fish is. We landed on a vertebrate with functional gills. The hagfish has functional gills. The hagfish might not be a vertebrate, which means it might fail the first condition entirely, and the whole tetrapod problem we raised earlier might dissolve. Except that molecular data suggests that it is a vertebrate, in which case the problem comes roaring back. And even if we accept the hagfish as a vertebrate and therefore a fish, now we have to reckon with the fact that it is so distantly related to everything else we call a fish that it makes the category incoherent in a completely different direction. The hagfish is so far outside the rest of the fish family that some biologists have argued the real question isn't whether tetrapods are fish, me, you, even whales, it's whether hagfish and everything else should even be grouped together at all. So, let's conclude. In the most elegant way, the hagfish doesn't fit into our categories, not because it's weird, though it is very weird, but because our categories were never built to accommodate something this old. The hagfish predates jaws, it predates paired fins, it predates almost everything we use to define and distinguish major vertebrate groups. It is, in a real sense, a living remnant from before the rules were written. Every time we write a new rule to define what a fish is, the hagfish either breaks it or slides through it on a wave of structural protein slime. And the tree of life just keeps branching. Thanks for watching.